Assalamualaikum warahmatullahi wabarakatuh. And hi everyone, my name is Wanzu Irfan Wanzu Kifli, and I'm the leader of the project that called IoI-Driven Smart Humidity Control with real-time monitoring. I'm working on this with an amazing team. First, Wan Shafi Aiman, Wan Anwar, Muhammad Faizul Ishraf, Muhammad Nazri, Muhammad Dini Humaidi, Muhammad Wardi, Wais Wajdi, Muhammad Yazid, Wan Muhammad Hazid Nur Iman, Wan Muhammad Azman, Ahmad Amar Najmi Najmuddin, Muhammad Mukris Wafiq, Muhammad Masri, and the last one, Muhammad Amar Amshar Muhammad Azhar.
Right, let us begin with the introductions. Indoor farming is becoming super important for a city where space is tight and resources like water are limited. But one big problem is controlling humidity. Plants need the right humidity to grow well, but using traditional method to manage it is exhausting and often waste resources like water and electricity. This not only reduce how much food can be grown, but also make farming less efficient. So, we ask ourselves, how can we make this better?
Maintaining proper humidity level is essential for indoor farming, especially in urban areas with limited land and resources. Traditional farming methods often result in inefficiencies such as excessive water usage and reduced crop yield. So, we created the IoT-driven Smart Humidity Control with real-time monitoring to monitor and control humidity in real time. Imagine this. Sensor that keep track of the environment, a smart system that adjusts itself automatically, and an app that lets you check everything from your phones. It's efficient, reduces waste, and makes farming so much easier. Plus, it's scalable, which means it works for small indoor setup and even larger farm.
Now, let us discuss the objective of this project. Alright, the first one is to develop a humidity control system integrating real-time monitoring and automated adjustment using IoT-based sensors and microcontrollers. And the second one is to reduce resource wastage by maintaining precise environmental conditions and minimizing manual intervention. And the last one, to create a scalable solution for sustainable indoor farming, contributing to global objectives such as SDG 2000.
Next, we move to the methodology of this project. The main focus of this project is to design a humidity management system that operates automatically and efficiently. The key components and materials, or we can call as a product, the first one is we have DHD 22 sensor, which is to measure temperature and humidity level, and YL69 soil moisture sensor to monitor the soil moisture content. And we have HESC SR04 ultrasonic sensor, which is to track the water level in the tank. And we have ESP32 model MSU as a microcontroller that process sensor data and control the system. And we have Mistmaker module, which is to regulate humidity by increasing air moisture. And the last one, we have Blink platform, which is to provide real-time data visualization and allows remote control of the system. The system gather environmental data, process it, and active the Mistmaker when the humidity falls below 55%, ensuring optimal growing condition while conserving resources.
Okay, next we are going to the operational flow of this system. The system starts by activating the sensors to collect data, and then it connects to the Blink app for real-time monitoring. The sensors measure the environmental data like humidity, soil moisture, and water levels, and is sent to the ESP32 microcontroller. The microcontroller analyzes the data. If humidity drops below 50%, the Mistmaker are activated. Otherwise, the system continues monitoring. The YL69 sensor monitors and moisture, while the HSR04 sensor checks the water level in the tank. The data is displayed on the LCD screen and is sent to the Blink app for user access. The system runs continuously, ensuring optimal condition for the plant growth. Okay, now we are going to demonstrate how this system works. First of all, we are using the power bank as the power supply, and then the DHD22 sensor first detect a low humidity level. The data is transmitted to the Blink app for monitoring. When the humidity drops below 55%, the mist maker activates to restore optimal conditions. Once the desired humidity level is achieved, the system automatically turns off the humidifier, ensuring the resource efficiency.
Alright, so finally, let's discuss about the conclusion, which is the contribution to the society. Alright, the project optimizes humidity control for indoor farming, and it automates the process, reducing resource waste and manual efforts while improving plant growth. And the systems supports urban agriculture and promotes sustainable food production.